Hi friends, welcome to another edition of QuickTip videos brought to you by dataplatformcentral.com. In this edition of the QuickTip videos, let's see an introduction to Azure Data Explorer clusters and also an introduction to Kusto query language, the language used for querying data from Data Explorer clusters. Azure Data Explorer clusters are managed clusters which can be used for real-time analysis of data. The ability of Azure Data Explorer clusters to work on huge volumes of data will make them an efficient solution for doing data analysis on data coming from a multitude of applications, IoT devices, even hubs and similar kind of applications. Most often for doing high compute activities, we ingest data to Azure Data Explorer clusters, and inside the cluster, we can do variety of complicated calculations over real-time data, and the resulting data can be effectively visualized into dashboards which are available inside Azure Data Explorer. In this introductory section, we'll see how we can ingest data into a simple table created inside Azure Data Explorer cluster. For the sake of this illustration, we'll choose a set of files having some drugs related data stored inside an Azure Data Lake storage and ingest the data into a table created at runtime inside an Azure Data Explorer setup inside your Azure account. For the sake of this illustration, let's consider an Azure account which has a storage account called Wisdom Files and have a container inside that called a DrugDB, which is storing 4 test files which contains the data about drugs. The intention behind this illustration is to create a table inside an Azure Data Explorer cluster which is going to be set up inside the same portal and load the data from these files onto the table. Now let's see how we can create an Azure Data Explorer cluster. For this, go to Home, search for Azure Data Explorer clusters. You will be immediately provided with the option to create a Data Explorer cluster. Click on Create Azure Data Explorer cluster. You have to add a name for your cluster, and you might also have to select a resource group if you don't have one already. I have already one resource group defined, so I'm not going to create a new one. So inside the cluster, I'm just going to name it as like training demo AD cluster, and I'm keeping all the other properties in its default. If you want, you can select a workload also, like what kind of workload you want: dev test, storage optimized, compute optimized, heavy compute. That really depends on what you want to do with your data. If you want to do really complicated calculations, you have to select a compute optimized one, or if you are really dealing with large amounts of data which has to be in the main memory and you want to do some applications with that, then you have to go for storage optimized. In my case, because this is a test demonstration, I am going to select dev and test. And keep in mind that the cost incurred will depend on the type of the workload that you are choosing. For example, for compute optimized and all these cost, the per hour cost for this would be very high. So depending on your exact workload, you need to choose a corresponding option for the workload so as to ensure that you don't incur more costs. So I'm going to just select it as dev test for the time being, and I'm just keeping it as the standard E2 cluster. There are also other types which is available. It depends on like how many resources you want in your clusters. So I'm just keeping it with the default, and I'm just giving review plus create. This will validate and it will create the cluster. So it's validated now, and now we have been provided with the button to actually create the cluster. So once it starts creating the cluster, you can see that it is already submitting the deployment, and the progress will be shown on the leftmost menu, and it will take a while before the deployment gets completed and the cluster actually gets created. So as you see now, the deployment is in progress, and shortly you can see the cluster being created. Wait for the deployment succeeded message to arrive in the notification, which means that your cluster has been successfully created. Keep in mind that it is going to take a while before the cluster gets actually created because it's a long process. So you need to patiently wait until you see the deployment succeeded message. Once that is done, you can go to the resource either by clicking the go to resource button on the notification or directly on the name of your cluster that you have created. So once you go inside the cluster, you can see on the overview page the details on what the cluster is about, the URI and all the other properties. When you scroll down, you can see the cluster creation steps. So first step is the cluster creation, which is already done. Now you need to create a database inside the cluster, and then you need to ingest data into the database. There is a step-by-step wizard which will automatically help you to do the ingesting of data. So let's see first how we can utilize the wizard for ingesting the data, which is currently inside an Azure Data Lake storage, and we are going to use the ingest wizard to ingest the data from the files onto a table which we are going to create inside the database we created in our Azure Data Explorer cluster. So first we will click on create database to create the database. Again, give some name for the database. So I'm going to just give like drug data analysis, which is what the database is supposed to do. And there are two properties associated with the database. One is the retention period, which indicates up to how much time the data has to be persisted within the database. Based on the value that you set for the retention period, after that particular period is elapsed, all the data that is present inside the database will get purged. This will help you to avoid incurring extra charges. Suppose you want the data to be only for a short period of time. Instead of coming back and deleting the data yourself, you can set a retention period so that after the retention period, the data gets automatically deleted by the system itself. Similarly, for quick querying and for quick response times, you can also set a cache period during which the data would be available inside the cache for querying, and all your queries will perform much better based on when the data is in the cache. Once the data age goes beyond the particular amount, it will be dropped from the cache and new data will get filled in. So let's leave it at the default value for the time being, and let's click on create. So this will now create the database. As before, you can see it in the notification regarding the progress of the creation of the database. So once the database gets created, you can see that the wizard will automatically move to the next step. So now the database is created. You can see that on your wizard, you can see step 2 is now completed, and now it's the step 3, which is the ingestion step. Now we need to ingest the data from our storage, Azure storage, data lake storage onto the table. So you can click on ingest new data, and you can select the account which is associated with your Azure portal, and it will automatically take you to the wizard which is used for ingesting the data. By default, the database will automatically be created. For the table, you need to select an existing table or create a new one. Because in this case we are doing it for the first time, I am going to create a new table called drug details, which is going to hold these details. Now keep the source type as from blob itself, because we are going to get the data from blob source. And then it has a property called links to storage, where you need to give the full URL for your storage account. For getting the URL, what you need to do is like go to the home page of your Azure portal, click on the storage account, go to the container, and inside the container go to the file which you need to ingest data. For the sake of this example, I am going to take the first file from this group of files. Click on the ellipsis, and there is a property called generate SAS. Click on generate SAS, and you can see that there is a property called generate SAS token and URL. Click on that button. It will automatically generate the SAS token and the SAS URL for you. This is the URL that you should use, the blob SAS URL. Click on that copy icon near to that so that the URL gets copied to your clipboard. Come back to your ingest new data wizard and paste this value onto the link to storage. It will automatically do the evaluation, and once it finds that it can connect to the particular file, it will automatically give you the edit schema button. Click on edit schema button. It will show you the details of the data which is coming from the particular file that you have selected. So you can also select the type of the data format here. So here we are using a CSV format, so it will automatically default to CSV. If it's a different format, you can select a set of formats based on what data it is coming from. So it supports only a handful of formats like JSON, PSV, TSV, Avro, Parquet, etc. So in this case it's a CSV, so it will automatically take the data as CSV, and it will automatically create a mapping, which is, it will name it as drug details mapping. Remember to click on include column names to ensure that the wizard correctly identifies the column headers from the first row of the file under consideration. Once this is done, click on start ingestion to start the actual ingestion of the data into the table. Once it is done, you can see the preview of the data that is being loaded to your table. This means that the ingestion has been completed successfully. Once it is done, you can click on the query on the top and it will lead you to the query window. Inside the query window, you can type the name of your table and click on run so that you can see the total number of rows that is loaded into the table. The result shows that there have been 1000 rows which are loaded into the table from the blob file which is stored inside your Azure storage account. So this gives you an illustration of how the wizard can be used for ingesting data from a Azure data lake account file to a table that is created inside your Azure Data Explorer cluster. Now let's see how we can ingest data to a table inside Azure Data Explorer by using Kusto QL queries. So Kusto QL or Kusto query language is the programming construct used inside Azure Data Explorer for performing DML operations. In this case, we are going to use a create table script to create a new table and use ingest statement to ingest data into it programmatically. To start off, let's first create the new table. So for that, I am going to use the scripting from the old table itself to create a new table with the same structure. I'm going to name it like drug details _1 _q to indicate that this is a table which is going to be populated using the query. So when I create this, the table will get created. You can see that in the Explorer as well that the new table is now created. Now we are going to use ingest into statement to ingest data into this table. So for that purpose, I am going to go to another window with the ingest statement on. The syntax resembles insert statement in a proper SQL language, and the syntax is like dot ingest into table, the name of the table. So here we have to use drug details _q, and for under that we have to give the complete URL for each of the files that we are going to ingest. Again, for getting the URL, we need to go back to the storage account and click on each of the files inside that from which we want to ingest, and in the properties we need to select generate / property, and you have the button available on the bottom which says to generate the SAS token URL. Click on that to generate the URL, copy the URL, come back and paste it within this. The H on the beginning of that URL indicates to obfuscate the SAS key which is generated, which means that the key will never get stored inside. That's a security mechanism so that nobody will be able to see your SAS key that was generated. So use that to avoid the key being shown in plain text. So we have one more file which is pending, so I am going to put that also at this. Again, go to that file, generate SAS, click on generate SAS token and copy the generated token. Again, come back to the window and paste it as the fourth. each of these files contains 1000 records, so we are going to ending up with around 4000 records. And with ignore first record equal to true is required because all our files have the header as the first row. If you are not including this property, the header row will also get included inside our ingestion. Let's run this now, and you should see a success message. Yeah, so the has errors is false, which means that the execution of the statement was a success. So now if you go and check the table, you can see that the table will have around 4000 records. We can do that. We can just type the table name, select it, and click on run. That's how you see the contents of a table inside Kusto QL. And you can see that it contains 4000 records, which is all the records from the 4 files that we have used in our ingestion statement. So this is another way to ingest data inside a table in your Azure Data Explorer by using Kusto QL or Kusto query language. This is in many ways similar to the normal SQL statements, but a slight syntactical difference will be there. That's the. But generally the constructs almost resembles each other. Before we wrap up the session, let's see some of the basic clauses which you can use inside Kusto query language so as to get the results from your table. To start off, you just need to specify the name of the table and click on run in the query window so as to get the complete result set from your table. So as seen in the example, you can see that all the 4000 records from the table gets selected. Now for adding any more clauses to it, you need to use pipe symbol. So add a pipe symbol and immediately you will be provided with a list of options that can be used for applying the clauses. So now we'll start off by applying a symbol filter clause by using a where condition. So I'm going to use where we have a column called company in our table. I'm going to check for the rows which contain pharma word inside the company. So if I run this now, I'll get only the results within this table where the company has a word pharma in it. So when I click on this, you can see that the result set has now been dropped to 589 records, and all these 589 records have the name pharma within the company, like Novartis Pharmaceuticals, App Pharmaceuticals, etc. So this is an example of how to apply a symbol filter. And of course you can combine multiple filters within this by using the keyword and. So what I'm going to do is, like, I'm going to filter from this only the cases where in stock equal to 1. So there is a bit column inside this which indicates whether the particular item is in stock or not. So I am actually checking for those items which are currently in stock. So here we are using two filtered conditions separated by a logical AND. So now if you run this, you can see that your result set will further reduce from 589 to 443. And if you check the in stock values, you can see that all of them have their in stock value as 1. Since in stock is a boolean field, you can either use equal to 1 or you can either use equal to true. Both will work. You will get the same for 43 rows. So now you have seen how to apply a symbol filter and how multiple filters can be combined. Now let's continue and apply a clause so as to restrict the number of rows returned by our result set, just like the limit clause in MySQL or top clause in SQL Server. So here you can use the clause take. You can use take of 10 to indicate that only return me 10 rows from this result set. So you will get only the 10 rows from this result set. Now you have not specified any orders here, so it's giving a random 10 rows. Now what if you want to specify an order also? Again, that is almost explicit that you have to use a order by clause. So you need to use an order by clause and you can specify the column. So I'm going to now order it by means of brand. And when I click on run, you can see that the 10 rows that you get will be based on the sequence of the brand. One thing to note here is that you will get it in the descending order of the brand, not on the ascending order of the brand. So that is one thing you need to be careful here. So if you want to make it in SQL, if you see, it's the ascending is the default option. Here descending is the default option. If you want to get it in ascending mode, you have to specify ASC and you will get it in ascending mode. And here the order of sequence is the order in which you are specifying the query. So here first the filter took place, then the top 10 from the filter took place, then the order by took place. If you want to first sort it and then get the top 10, you need to make it like this, so that it will first sort it by brand and then take the top 10. So now if you see, it's all A's, indicating that it first sorted by the ascending order of the brand and it took the 10 from that. Or if you want it in descending order, remove the ascending, you will get all based on the last ones, V, S, T and all like that. So this is how the query executes in the state of Kusto query language. So based on the order in which you are applying, each of the clause gets applied on the previous result set. So here it started off from the total result set of the table, applied a filter on top of it, then sorted it based on brand descending order and then took the 10 from it. So this is how Kusto query language gets executed. Hope this quick tip session helped you to understand the basics of Azure Data Explorer clusters and also how to use Kusto query language so as to query the table data that is being loaded into the Azure Data Explorer clusters. As always, make sure you let us know your feedback and keep following Data Platform Center for getting quick tip videos like this. Thanks all and have a nice day.